Hello, we are excited to present this short tutorial on system architecture in SysML and 3D CAD simulation. This new tutorial will be presented by me, Saulius, first part of this presentation, and then actual step-by-step demonstration will be done by the Peter. What's the motivation? So this is one of the most common MBSE ecosystem requests in SysML and 3D CAD integration. This is alignment between two major disciplines, system engineering and mechanical design. In this tutorial, we will present out-of-the-box method how to leverage simulation orchestration tools like Process Composer from 3D Experience platform to integrate models SysML and 3D CAD to enable simulation and analysis. This tutorial enables application of this method and tools in multiple domains and use cases. First of all, we want to introduce a few MBSE model-based system engineering and digital engineering concepts. First of all, engineering V. When we are integrating system architecture and mechanical design in order to define the requirements for the design. And that's an iterative process here on the left side because new requirements are coming, right? So we are going through the system architecture models in the SysML, let's say if we are using SysML, and then mechanical and other different engineering disciplines. So this is very important part. And then the verification and validation comes back. Again, it's important part to have that as a part of the simulation. Then also this is as a part of the strategy, right? So here we have integration framework presented by Sandy Friedenthal and also Navier. And we see here the integration between system architecture and analysis, mechanical design, requirements, electrical design, right? So we will cover analysis, which could be many tools available, most cases external tools, in the context of the mechanical design, which is 3D CAD, right? Again, very popular, and how to enable any type of analysis in context of system architecture. On top of that, there is life cycle when we have process of product development. We start from the concept needs, and then we go to the requirements review, system requirements review, preliminary design review, critical design review. All the engineers on the team members, project managers and business sits at the same table, and they are collaborate and increasing maturity of those models at the same time integrating those models. And here we see that from the simulation perspective, because we are talking about orchestration of the models for simulation, right? So this is the last step. We have modeling, we have execution, we have integration, and then when we are integrating and enabling this orchestration, we get ability to optimize on the architecture early decisions in the process. For the design, we are leveraging engineering and business platform environment, 3D experience platform. And it is very famous for the CATIA part, 3D CAD, like SolidWorks, CATIA. But there is also Simulia part, which is talking about workflow automation, different type of analysis with CAD, and not only with CAD, with other type of the models. Manufacturing analysis and definition. Biovia is material science, enterprise collaboration with Anovia, like all the PLM backbone and change in configuration management, and then dashboarding and intelligence and all other stuff related to that with the NetVibes. And behind the scene is all of this is model based. So this enables actually collaboration and parameterized simulation, and this comes as a semantically rich information for the integrations. From the MBSE referential, we see here that we start from the system of systems, That could be like in Unified Architecture Framework, DODAF, Enterprise Architecture. Then we go to the system engineering with the SysML. And then we see here the design, all the design disciplines like mechanical, optical, fluidic, electrical, and optical fiber. Behind the scene, we have so-called RFLP-based meta model, which is common meta model enabling to interchange and enabling integration of those models out of the box. Now back to the actual tutorial workflow. So Peter will present it live, and here we want to demonstrate what we will cover in the short agenda. So first of all, building or importing 3D CAD. And here we have this 3D CAD as mechanical design coming from CATIA, SolidWorks, could be also another tool, you know, external one. And here is quick demonstration how that looks like. So this is internal app, you know, you can modify, create, import, use that for the analysis. And talking about analysis, so we need to add this 3D CAD to executable workflow. For that purpose, we use simulation workflow automation tools, and we'll start with the optimization process composer app, which allows you to drag different adapters and the hundreds of different adapters. And one of them is for 3D CAD. As you can see here, we take the same 3D CAD which we created, and we drag and drop to enable parameterized access to 3D CAD in order to change those parameters later from system architecture and get results. So in our case, we are changing the characteristics of the shape and we get volume out of the box, right? Calculated. Then we package this whole workflow as a parameterized template, which is reusable as a link data, so we can actually see those parameterized inputs, outputs. And then next step would be to take that template. Here you see drag and drop to the CATIA magic parametric diagram, and you see you get parameterized constraint constraint block where you can link to the value properties, link to requirements, link to the functional analysis, link to anything, and enable parameterized analysis through the behavior like activity simulation or the parametric simulation, as we can see here, including requirements verification out of the box. So just drag and drop, you know, and you get that link, and then you run simulation in SysML as you would do in a regular case. And also you can simulate, not only that you can simulate, we see here, but also you can monitor results. And those simulations could be various, right? Using different adapters for Process Composer. And Process Composer can do results analytics. And here we see like a performance study where we can see a log of execution and also what are the inputs coming from the external, you know, source like CATIA Magic, like Cameo, and also results. So that's the workflow which we will present. And now, stages for Peter.
Hi everyone, my name is Peter Drozdowitz. I'm here with Dassault Systems, and this video is going to essentially be a tutorial on how to connect your 3D CAD models to your Cameo Systems modeler. So this is going to be a 5-step, 5-part video, kind of highlighting every individual step that you need to achieve in order to get that full integration up and running. So the very first step and the very first part of this video is going to be actually building your CAD models and then mapping that CAD model to your Process Composer. So we're going to get this started by actually showing you how to get to where you'd want to be building your CAD models. And in this case, within your 3D Experience app, you have these roles. And these roles, one of these roles is known as Part Design. So this Part Design will end up opening your CATIA app for you to actually work and build your products in. So what we're going to do right here is we're going to actually get started. We're going to build a relatively simple model here for the sake of the tutorial. And in order to do so, we'll start by creating a sketch. So down here, you'll click on Position Sketch, and you'll be able to kind of build whatever it is that you want to build based on what kind of drawing or design that you want to create. So as you can see right here down in the essentials, You can kind of go for a more box look, or you can create maybe something that's more rounded. In this case, I'm going to be creating a circle because we're going to actually build a cylinder. So I'm going to make sure to constrain the cylinder and give it a generic length. Let's just say we make the diameter 10 millimeters. And then once you build your sketch and you finish sketching your product, there's a bunch of other tools for you to utilize here, but you would want to then exit your sketch here, where right here it says exit app on the bottom left. And now you'd actually want to create your part body, which is also relatively simple because when you're trying to go and build your model, you can click on this pad button, which is essentially going to extrude your sketches to whatever design it is that you want to show. So what we're going to do here now is we have our cylinder that we have built, as you can see, and from this model that we have designed and that we've built, we can actually go and from the values that we assign this model, we can go and assign these values to our next step, which is going to be our process composer app that actually combines our CAD models to your Cameo Systems modeler. But before we move on to that, I'm going to actually go here into the essentials, into the model, I believe it's the model tools app. And within these model tools, one of these tools is called the formula tool. And we're actually also going to create a quick little volume formula to measure the volume of this cylinder so that we have an output for us to work with. So as you can see right here, we are going to create a new parameter of type volume. And when we create this parameter, you can see that this volume has now been created. And this volume needs a formula as well. So when you want to create the formula, you're going to want to go here to part measures, and then in this case we'll just use the smart volume formula. So you'll double click on that to input the smart volume in, and then you'll double click the you'll click on the part body that it is you want to calculate the volume of. And as you can see right here, we have now calculated the volume of the cylinder. We'll press OK. Once this is created, now you can see here this volume parameter that you had just added, you had assigned a formula to it, and now it is a fully active formula that also calculates the volume of your cylinder. So we're going to press OK. And now that we have that formula assigned, we can go here to parameters and see that our volume is assigned to the cylinder, which means now that you have kind of set up your CAD model, you have values that you want to work with, and for example, you have your radius, you have your height of your cylinder, you have all these internal values. It is now time for us to move on to the next step of this process. And the next step of this process is going to be utilizing the process composer to connect your CAD to that specific tool. So we're going to want to go, so now that we are on the next step, we're going to be going here, so back to 3D Experience, and we're going to be looking for a tool. And this specific role that we're looking for is called Optimization Process Composer. So we're going to open up the Optimization Process Composer. And as you can see here, there are activities that you can add onto this specific process. And the process that we're going to be focusing on today for our CAD models is going to be this little specific tool here called 3DX Parameters. So what we're going to do is we're going to take this and we're going to drag it and put it onto our start to finish process. Now within here, as you can see, if you open up the box that is the 3DX Parameters, we don't actually have any values assigned to this box yet. We don't have any, and because of that, we have to search by pressing this little search bar here, and we go back to our cylinder, and we're actually able to select our shape, that is our cylinder, and as you can see here, all of the values that are within that cylinder are allocated to the part that you've selected. So for this sake, we're going to be selecting all of our inputs that we had assigned to our our 3D shape, that is our cylinder, and that is going to be the height here, this length, and then this radius of our circle. And then we're going to press OK. I'm just going to click Show Selected, and then we're going to press OK. So now we know that you now have mapped specific parameters from your 3D CAD model to your process composer. But we also haven't mapped the output, which is the volume of your 3D CAD, to the process composer as well. So we're actually going to create another 3DX parameter, and this 3DX parameter is also going to be using the same search and the same part. But in this case, because now that we're working with the 3DX parameters that we have and we want to export these parameters back out as an output, we're going to be selecting the mapping direction from the 3DX parameters to the activity, because this is the volume that we want to search back. So we'll click on the 3D shape again. It'll show us all the values, but in this case, now we're selecting the volume parameter. And once we press OK, now we know that our full process, that is our process composer, has mapped all of our directions from both the initial input parameters that you would assign to your process to the output parameters that you will get after working with the process composer. So now that we have done this, we can control and save this process composer. And something that's also important and worth mentioning is within here, within the process composer, if you open up the data flow tab, you're able to see that within this specific activity box, there's no values that have been added to show the mapping direction between the process and the parameters. So what we're going to do here is we're going to go to our parameters and make sure to also assign and add new parameters that we had just added from our initial values. So we'll have obviously our length. You'll have your radius, and then you'll have your volume. And volume is going to be your output. So and then you can assign a bunch of random values to these, since they'll get modified in the future. Let me delete this one really quick. Let me cut this. It was accidentally added it. I apologize, and let me just delete this really quick. There we go. And then we can just, depending on, we'll just go with some random values, because these values that you assign here will actually get changed once you run through the process composer, but we're just assigning some generic set values for this process. But now, if you go here, you can actually see that you have your length, you have all these values within your activity, and you want to make sure that within the process composer, the specific values that you have in your process composer are mapped to your 3DX parameters, so that when you're actually doing the calculations and modifying values in your CAD, those values will get updated within your process composer. So we're going to go here and add our length, we're going to add our radius, and then we're going to add our volume. And if you press OK and apply here, you'll see now that we've mapped our 3DX parameters to generic parameters within the 3D Experience app. Now that I've shown you how to get your general process composer set up, we're going to move on to the third step of this tutorial. And this third step is creating a simulation template for you to run and access within your Cameo app. So what we're going to do here now is we're going to go back to the 3D Experience tab, and we're going to open up in the search bar and look for, we're going to look for a specific app called the Process Experience Studio. So what you're going to do here is you're going to open up the Process Experience Studio, which is going to take you into your browser tabs, which is going to be different than your 3D Experience native app tabs. And within here, you have this option to create a new simulation template. So what we're going to do here is we're going to press this create button, and this is going to be called cylinder process. I'm just giving it a generic name for now. And you want to make sure your template type is one click. And from here, when you're searching for your content, you'll be able to search. We'll just search the word process. You want to look for, within the server that you're working in, you want to look for the process that you had just finished building. In this case, our simulation process is right here, process 61. So you're going to take that, drag onto it, and move it into this template content that's called, that's now here, process 61, and you're going to create this template. So by creating the cylinder process template, you can now see that within this simulation template, you have all your values from your parameters that are your length, radius, and volume imported into the model and imported into your simulation process. And now that we have that set up, you can press save. And we can actually use this process here within our Cameo Systems modeler to modify values and roles and do calculations within Cameo Systems modeler. So this step was really simple, just creating your simulation template and making sure that everything is set up. So this final step that I'm going to be showing you guys is the actual Cameo integration with the simulation template that you had created using your process composer. So as you can see right here, I've kind of already set up an example, but I'll show and I'll do a walkthrough on how to actually build your parametric diagrams within your Cameo Systems modeler to actually connect it to your simulation templates from the 3D Experience app. So we're going to start by going here to File, and you're going to want to create a new project, and you're going to want to make sure it's a SysML project. I'm just going to write the word test. So once you're here and you're in your Cameo Systems model, you're going to want to start by creating a parametric diagram. So once you're here in this parametric diagram, you can go then to whatever simulation template it is that you're using. In this case, the simulation template we had built was the cylinder process simulation template. So we're going to go to that, drag it into your parametric diagram. It's going to ask if it wants to use the simulation profile, which you say yes. And as you can see right here, your simulation template gets populated within your Cameo Systems modeler. So now in order to actually set up the simulation within Cameo, you're going to need to do a couple more steps here, which is actually initializing your simulation. So you want to start here by creating a couple of value properties that you're going to want to assign to your cylinder. So we're going to create a couple right here. So we'll create length, and then we'll, and then we will go here and create a couple more properties really quick. So Control copy, and then rename these to radius and volume. So once you're here, you're going to also want to assign these value properties to specific types. In this case, we're going to be using reals because these are real values we're working with. So we assign them to reals. So now that these values are kind of quote unquote initialized, we have to make sure that they're connected to the actual simulation template. So we go to our parametric diagram wizard, make sure that, as you can see, length is mapped to length, radius, volume, volume. So you'll press OK, and it will help build and populate your simulation diagram. And then once you get to this point in the simulation, you can press this Run button, and you will see that your value properties would get populated down here below. Now, I have already, that is kind of just showing you guys how to actually physically set up your simulation template within Cameo. I've already prepared an example for us to work with, which is going to be this box process. So you'll have your length, height, and width, and volume in the box process. So we're going to start by running the simulation. I've created a couple of placebo proxy values that I've assigned to the box process. And you'll be able to see that when I'm running the simulation, you're going to see values get assigned and modified here, because what's going to be happening is based on the initial values that you assign within your Cameo Systems modeler to your width, height, and length, the volume equation that the Cameo Systems modeler is utilizing is based off of the 3DX simulation template that you had created using the 3DX parameters from your 3D CAD model. So we're going to take some time here to wait right now and observe what happens as the process gets initialized. So as you can see here, this is the process composer template, and you'll also be able to take a look at the log of what's happening within the process composer as it's running and as it's calculating these inputs and outputs. So as you can see, going back here, the simulation was initialized, and if we were to go here and start putting in a couple of random values, let's say 200, 500, and 1,000, right? If we were to go here and put these random values in for length, height, and width, and we were to run this simulation within Cameo, you'll actually be able to see that the volume itself gets changed, which is a really awesome feature and shows us that we have actually integrated Cameo Systems Modeler to your 3D CAD profiles, and now you can do multiple tests within just Cameo based off of your 3DX, based off of your CAD models, and therefore using that to help aid you in types of projects where you're trying to gather copious amounts of data that you want to take a look at within your Cameo Systems Modeler rather than just do modifications within your CAD models. In addition to both Cameo, though, you're also able to take a look at modifications that occur within your 3D Experience browser tab as well. As you can see right here, I've opened up this tab called Performance Study. So the Performance Study role is a way for you to observe what is going on within your process composer as it runs the 3DX parameter activity modifications. So if you take a look here in the log, this process is executed, and you're able to actually go into the inputs and outputs of the log and notice that you can get volume calculations based off of the length, height, and width within this specific browser tab, in addition to what you're working at within the Cameo Systems Modeler. And as you can take a look, going back to Cameo, the value here previously in the volume was different when we are working with those lower values, and as you can see, this volume has now changed as a result of me modifying these height, length, and width values that you can take a look at here. So this shows that not only are you able to look at calculations directly within Cameo Systems Modeler, but also once you've connected your process composer to your 3D CAD, you're also able to take a look at the values of parameters within just the browser tab. So if I were to go here now and change these value properties in just the in the Performance Study tab, and you run it within the browser tab itself, you will also be able to calculate the volume, or you'll be able to calculate formulaic equations that you want to look for based off of value properties that you've assigned to your 3D CAD model. So for example, let's say this box I'm working with, I want to see what X, Y, and Z is now for these new length, width, and height parameters. I'd be able to observe that within this Performance Study tab. Just ran, the process was completed. And as you can see now, the volume has been updated in accordance to the new parameters that you had inputted within the Performance Study that we're working within here. So another really awesome feature is you're not only able to take a look at modifications that you make within Cameo and take a look at updated values based on the inputs that you're working with directly in Cameo, but you're also able to utilize the Performance Study tab within the 3D Experience app to also make changes to parameters and updated values as a result of that. Thank you so much again for watching. I hope you've enjoyed this tutorial that shows you from bottom up how to start with your 3D CAD models and end up connecting those and integrating those 3D CAD models to Cameo Systems Modeler for usage when you're trying to calculate equations and do different types of case studies. So I hope this has been a very informative tutorial. I am Peter Drozdowitz with Dassault Systems.
Thank you, Peter. Now, as a conclusion, I want to talk more about the process composer as part of the workflow automation. So it's really powerful solution. There are maybe a few of them in the market available in general. This one is actually tight integrated to the design, to the analysis, and to the system engineering, as we are part of the same ecosystem. So I strongly recommend to take a look at it. And here we will want to show one more, one more process, how to do trade studies. So we get a system architecture of the possible solution. And then this is for the mission, for the jet fighter, which would be on the aircraft carrier with the limitation of the space it can take, but also with the characteristics of the mission it shall support, right? So we care about all different aspects of the, not only the jet fighter architecture, but also about the mission and environment in which will exist. So we package, we get that design of the jet fighter, and we want to connect them together with the system architecture, which will provide again characteristics of the jet fighter plus the mission characteristics. And we have different alternatives coming from architectural perspective. And also we can link to other models like through FMU, through Dymola integration. Specifically here, what we do, we actually take those models which we package in the process composer for the 3D CAD, for the aerodynamics, for the distance, how far aircraft can fly with this aerodynamics and this like fuel capacity, and we reuse them in the system architecture to run that analysis with those configurations, how far aircraft can fly. Then we can actually do that publishing of the model to the Teamwork Cloud Collaboration Studio to run simulations on the server side in order to perform trade studies, not with single model instance, but with multiple instances at the same time, which is possible due to the server-side simulation, which is available now, not in single instance, but in multiple not in single instance, but in multiple instances is now available with the server-side simulation on the Collaboration Studio Teamwork Cloud. And on top of that, now we are running with alternative architectures, which could be parameterized, configured, again, calling system model from the server side by process composer, changing those parameters and getting results, and then calling another characteristic, another configuration, and then storing results and doing results analytics, like sensitivity analysis and trade studies. And then that comes as update for requirements to identify optimal solution architecture. So this is a big picture of the proper way to do trade studies at the architectural level, doing them not in brute force, but actually doing them in the smart algorithms when we identify what the optimal inputs would be for the based on the optimization goals, which, as you know, could lead to million and billion of possible configurations. But if you use those advanced AI algorithms which are available out of the box, we can get the analysis done in the timely manner. On top of that, we have all of that, all those models which we use for analysis, 1D principal equations, lookup tables, control surface analysis, 3D fluid simulation, acoustics 3D simulation, 1D thrust analysis. They all exist with their own workflows, their own versioning, and they all managed in the controlled environment. Not only that we integrate them, but we actually have the versioning and integrated change and configuration management behind the scene as 3D Experience platform. And those models could be internal, could be external, so still we can manage the versioning. Okay, thank you so much, and we are looking forward to keep in touch and Let us know if you want to learn more about presented solutions for workflow automation, system engineering, or mechanical design.